With section 5, we want to talk about the importance of the characteristics of water based on the structure that we see of water. And so if you remember from our Lewis structure chapter, water has this bent molecular structure, 2 hydrogens and an oxygen with 2 electron pairs that are left over on the side. And this was, like I said, this was the bent structure coming from the AB2E2 chemical structure. And what was so special about this when we talked about the bent structure was that how that your electrons, because of electronegativity, would funnel over toward your oxygen. And so hopefully you remember that because of that, this molecule is polar covalent, meaning that this side up here is going to be a delta positive, and then this is going to be your delta negative because of the electrons funneling toward the oxygen. So why is water so special based on its structure is for this particular reason right here. It is going to be a very, very specific bonding type, and when it changes from a solid liquid to a gas, it also has specific characteristics that are only unique to water. So in your book, it talks about, first off, when you did your concept worksheets, the property of water is determined by this structure. And so in looking at this, since this is polar, how would you expect, if we were to talk about bonding, how would you expect for water to bond to itself in a physical change, like going from a liquid to a solid? And if this is the structure that we see, this being delta negative and this being a delta positive end, if we remember what polarity is like, it's almost like an ionic situation to where that you have an attraction of ends. So that tells me that if I have an adjacent water molecule around here, let's just draw them in like this, we're going to have bonds, and I'm going to use a blue line to show the bonds, that we have a physical change to where that if this is a liquid state at the moment, that I can have it solidifying because of a decrease in energy. I'm going to have bonding here and here. And so if you'll notice, the reason that you have such a change in density when you have liquid water going to solid water is because it creates all this natural air in between the water molecules, decreasing the density. Water specific in that because of its bent structure, it is going to be one of the only compounds to decrease in density as it turns into a solid and loses energy because of the way that it has to bond here. So the important thing for us to remember about water is that not only does it change into a higher volume as it freezes, but where I drew in these blue lines here, I don't know if you remember, but these are what we called intermolecular forces, because it took one water molecule and bonded it to a separate water molecule, and so we said those were intermolecular, like interstate highways. And so I'll write this over as a reminder, as in I-40 took us from Arkansas into Tennessee, 2 separate states. Intermolecular forces are going to take us into 2 separate molecules. What did we call these red bonds here? Intramolecular forces. So one of the things that it gives us in section 5 in your book is another reason why that water is so specific is because it is built on these molecules, the water molecule connecting to another water molecule in what we call hydrogen bonding. So hydrogen bonding is where that you have hydrogen that will bond to a phone, F-O-N, And so we call this hydrogen bonding, and I'll take my yellow highlighter here. And if you'll notice, the hydrogen is bonding to an oxygen, which is part of your phone. And then we have another hydrogen bonding situation to where this hydrogen bonds to an oxygen through those intermolecular forces. Hydrogen bonding is a very specific type of bonding that is extremely strong in its characteristic because of the one electron that is there for hydrogen and is connecting to those oxygens in that relationship. And so hydrogen bonding is another example of why oxygen is so unique. When we look at the last thing about the water, is that the physical characteristics of water turning into the different states is also very high in its molar enthalpy, which means the amount of heat that those water molecules can take in. It takes a lot of energy to break these intermolecular forces, those blue forces that I showed you a second ago. When we talk about those blue forces that are right here, anytime that you have, let's go the other way here, to where that you have a solid water going into a liquid, you have to essentially go in there and break these bonds apart. And so you noticed on the back page of your concept review worksheet that it takes 6.009 kilojoules per mole of energy, because joules measures energy, to break those apart. Water is a very high amount of energy to break those apart, which means that it can absorb a whole lot of energy before it actually changes temperature. That's why in the summertime, if it's been hot for a really a long number of days, the water still feels cool to us because it can absorb a certain amount of energy before it has to change temperature. Same exact reason, and a lot of you took physical science with me when we talk about, well, why does a saucepan, a little saucepan of water, boil faster than a spaghetti pot full of water? And it has to do with this molar joules per mole value here that we have written down, that the saucepan is going to boil faster because it has a lower mole value of water than the spaghetti pot. That smaller mole value of water is going to get to that magic energy value first compared to the other one. And so in the process of doing that and thinking about those energies that are coming and going, water has what we call a very specific, high specific heat, which means that it can take in a lot of energy before it actually changes phase from a solid liquid to a gas or back and forth. So in looking at all of those things, I would urge you to go back and look at that page 330 in your book, and you can write that on your concept worksheets. The concept worksheets are allowed to be used tomorrow on the test. And we will not have any calculations on the test like you see on that back page of the Section 5 concept worksheet. So do not worry about having to do that since I had to unexpectedly be out today. We can talk about those at a later date when we do actually use the enthalpy values. You are going to get the answers to the concept worksheet, and the sub will read those out to you. If you'll just correct those, they do not have to be word for what is written, just as long as your answers match pretty closely to what is written there, because you can use that concept review packet on the exam tomorrow. All right, I will see y'all then. You guys have a great day. Bye.